Hello matheNends! Welcome to my YouTube channel. So for today's video, we're gonna solve linear equation in one variable involving absolute value. Alright, but first things first, let's do some recall. Now, let's simplify this expression. For number 1, what is the absolute value of 3? It is what? It is 3. How about number 2? What is the absolute value for negative 5? The absolute value is 5. How about number 3? It is 3/4. Now for number 4, what is the absolute value of negative 3/4? As we all know, when dealing with absolute value, there is no such thing as negative. So for this one, it will be 3/4. Now for number 5, what is the simplified form? Okay, we all know that negative 5 plus 3 is what? Negative 2. Now what is the absolute value for negative 2? It is 2. Okay, we're done simplifying it. Now let's define terms first. So linear equation is a term used to describe an equation with 1 as the highest degree. I know you're already familiar with this. 1 as the highest degree. Say for example this one, x. The highest degree is 1. Okay, for the next term, absolute value. Absolute value of a number is the distance from the centermost value of the real number line, which is 0. Again, take note that there is no such thing as negative distance. That's why when we're dealing with absolute value, it is always positive. Now, linear equation in one variable involving absolute value. This means that the mathematical expression are found inside the absolute value notation, containing variables in the first degree form. Okay, what is the symbol for absolute value notation? The symbol is this one, if you observe in our expressions. So we have linear here. So that means the linear equation in one variable involving absolute value notation. Okay, let's have here an example. So we all know by just simply looking at this problem, we can say that the x here will be 3 for us to satisfy the expression. So the absolute value of 3 is equal to 3. Okay, let's show this one. Okay, let's show it. First, we have to rewrite it. So the absolute value is equal to 3. Now we all know, we can assume already that the value of x to satisfy this equation is 3, right? So 3, okay, 3. Okay, what is the absolute value for 3? Is 3. Equal or not? It is equal. Now, do we have any value of x that will also satisfy this equation here? Do we have any? Okay, let's try negative 3. Negative 3. Let's check if this will also equal. Okay, negative 3. What is the absolute value for negative 3? It is 3. Equal or not? It is equal. It means that 3, and negative 3 are the solutions for this equation. So if we are going to rewrite that, it will be, the solution set will be 3 and negative 3. So that's for the solution. Okay, let's have another example. This one. The absolute value of x is equal to 3/4. Okay, let's solve this. So we can assume already that 3/4 3/4 is the value of x to satisfy our equation. So let's check it. So what is the absolute value for 3/4? It is 3/4. Equal or not? It is equal. So one of our solution set is 3/4. Now, what if it's negative? Will it still satisfy our equation? Okay, let's check. Negative 3/4. Okay. So what is the absolute value for negative 3/4? It's still 3/4. Equal or not? It is equal. Okay. This this should be question mark. Okay. So our solution set will be what? Since both of the negative values in here, I mean this one, this x here, take note that this is our x. Here, x, our x. So this 3/4 and negative 3/4 is our x. It means that this is our solution set since it equates the equation. So our solution set is written as SS 3/4 and negative 3/4. This would be praised. Okay, take note that you can actually interchange the uh, the values here inside the solution set. You can write first the negative 3/4, then followed by 3/4, as long as it's inside in our bracket, in our solution set. Okay, let's have some generalization based on the example I have given a while ago, the example 1 and example 2. So, the absolute value of x is equal to c, where c is our constant. Now, the possible values will be x is equal to c or x is equal to negative c. Now, let's look back on our example 1. Our example 1 is this, right? So, in here, our c is 3. So, x is equal to 3. Or x is equal to negative 3. So by simply looking at this one, we can already assume that the values for example 1 is 3 and negative 3, following this generalization. Now, let's have the example 2. It was what? It was 3/4. Now, for x and negative c, 3/4. If you can still remember our discussion a while ago, it is same as the solution. Same, I mean, the values of x are the same. 3/4 and negative 3/4. Our solution set, okay? Right? It is the same with our. Let's have these statements. So, In solving a linear equation in one variable involving absolute value, there are two statements that we have to follow. For the statement 1, we have to take the expression inside the absolute value notation and equate it with the positive value of the right-hand side of the equation. For the second statement, we have to take the expression inside the absolute value notation and equate it with the negative value of the right-hand side of the equation. Okay, let's have an example for us to have a clearer understanding on this statement. So let's have example 3. Okay, for the statement 1, as we all know, our equation here is the absolute value of 2x is equals to 16. So in here, we have to take the expression inside the absolute value notation. So the expression inside the absolute value notation is what? 2x, right? It is 2x. So let's write 2x here. Let's take out 2x. Now, the next step is to equate it with the positive value of the right-hand side of the equation. As we all know, this is our right-hand side, right? So let's equate it. The positives of 16 is 16. That's for statement 1. How about for the statement 2? Okay, we have to take again the expression inside the absolute value notation and equate it with the negative value of the right-hand side. So what is the negative value of our right-hand side? This what? Negative 16. Okay, let's continue solving this one. Okay, let's rewrite that. Uh, 2x is equals to 16 and 2x to negative 16. Now, as we all know, we have two statements, right? So, we have to put our 2, separate the two statements. This is for the statement 1 and this is for the statement 2. We have to put or, okay? Now, let's solve this first statement first. Okay. So, as we all know, based on our past discussions, what are we going to do with this one? We have to divide. To eliminate 2, we have to divide 2. So, we will be left with x. This will be cancelled out. And we are left with x is equals to, what is 16 divided by 2? It is, it is 8. Now, for this one, let's do the same process. Let's divide this by 2, so we'll be left with x. I know, this should be not negative. Alright. So, this will be cancelled out and we're left with x is equals to, what is negative 16 divided by 2? It is negative 8. So, when we divide numbers having unlike signs, the answer will be negative. So, this is our x. Now, can we already assume that this is our solution set? You can, but to assure if it is really true, let's do some checking. Okay, let's do some checking. Okay, checking. In doing the checking, let's copy the original equation, which is 2x. Okay, and 16. Now, first, let's substitute this value here. The x is equals to 8. So, the absolute value of 2 times 8. And do not forget to write question mark. Okay, so what is 2 times 8? It is 16. No, it is 16. Sorry. It is 16. 16. So what is the absolute value of 16? It is what? It is 16. Now, equal or not? It is equal. So, one of our solution set is this 8 here. 8. Okay, let's check if negative 8 is also our solution for the given equation. Okay, let's do some checking again. Okay, so let's substitute negative 8 to the x in our original equation. So it will be what? 2 times negative 8. Negative 8. Why am I writing 18? And 16. Now, what is 2 times negative 80, negative 8? It is what? It is negative 16. And do not forget to copy the absolute value notation. 16. Okay. Question mark. Now, what is the absolute value for negative 16? Okay, the absolute value for negative 16 is what? It is 16. Now, equal or not? It is equal. It means that negative 8 here is also our solution. So, we are going to write it in our solution set. Now, this is our final answer, our solution set. So, 8 and negative 8 is our solution to the given equation. Okay, let's have another example. What if we have here the absolute value of 5x is equals to 25. Okay, let's write it. Following the first statement, we have to what? We have to take out the expression inside the absolute value notation and equate the positive value of the right hand side, which is the positive value of 25 is 25. And we have to put or to separate the statements. Okay, so again, for the second statement, we have to take out the expression inside the absolute validation and equate the right hand side to its negative value, which is negative 25. Now, let's solve this first statement first. So, we have to what? Divide this by 5, right? For us to be left with x. Now, we can cancel this out. And we are left with what? We are left with x is equals to what is 25 divided by 5? It is 5. So this is our x. For the statement 1. Okay, let's solve the statement 2. So same process. Let's divide this by 5 on both sides. And we can now eliminate this one because 5 divided by 5 is 1x, or simply we just have to put x here. So negative 25 divided by 5 is what? Negative 5. Okay, let's check if our 5 here and negative 5 is our solution to the given equation. Let's check by doing the checking. Okay, let's have blue color. Checking. Okay, in doing the checking, we have to what? Copy the original equation, which is 5x is equals to 25. Now, let's substitute this value to the x. So, 5 times 5 is equals to 25. And we put question mark. So what is 5 times 5? It is 25. Oh, and copy the absolute value notation. Okay, this is a question mark. Okay, so what is the absolute value for 25? It is 25. Now, equal or not? Equal. It means that 5 here is one of our solution set. Oh, let's write 5 here. Now, let's do the checking for the statement 2. Okay. Checking, again, we copy the original equation, which is 5x. Okay. 5x is equals to 25. Now, let's substitute this value of x, negative 5. So, 5 times, no, 5 times negative 5, and the absolute value. Okay, that's a question mark, class. So, what is 5 times negative 25? It is negative 25. Now, what is the absolute value for negative 25? It is 25. Equal or not? It is equal. It means that our negative 5 here is also our solution. So let's write it in our solution set. So our solution set is 5 and negative 5. Okay, let's have another example. Example 5. Okay, so for the statement 1, we have to take out the expression inside the absolute value notation, which is x, x minus 7, and equate the right hand side, the positive value of the right hand side, which is x. Then let's put and for the second statement, take the expression inside the absolute value notation and equate the negative value of the right hand side, which is negative 3. Okay, let's solve the statement 1 first. So, how are we going to eliminate negative 7 here, since negative 7 is beside x and we are only have to x. We only need the x to solve for the x. Okay, so to eliminate negative 7 here, we have to what? We have to add 7 on both sides. So take note that you have to what are you going to do on the left hand side? You also have to do it on the right hand side. So this will be what? This will be cancelled out because negative 7 plus 7 is equals to 0. Okay, now we are left with what? We are left with x, and what is 3 plus 7? It is 10. Now we have our x here. What about for the second statement? Again, same process. Let's have to add 7. And this will be cancelled out. And we are left with what? X. Now, what is 3 plus 7? What is 3 plus 7? Here. What is 3 plus 7? It is positive 4. Now, let's do some checking to check if 10 and 4 is our solution set. Okay? Let's do some checking. So, checking. And by doing the checking, we have to copy the original equation. X is equals to minus 7 is equals to 3. And let's substitute this 10 to the x to any x on the original equation. This is 10. This is 10 plus minus 7 is equals to 3. And we put question mark. Now, what is 10 minus 7? It is 3. Okay. 3. Now, what is the absolute value of 3? It is still 3. Equal. This means that 10 here is our solution set. Okay, let's write it here, 10. Now, let's check if 4 is also our solution set by doing the checking. Okay, copy again the original equation. So let's substitute the value of the 4 here to the x of the original equation. So here is the 4 minus 7 is the 3. Now, what is 4 minus 7? It is negative 3. Now, what is the absolute value for negative 3? It is 3. So, equal or not? It is, of course, equal. It means that 4 here is also our solution set. So, that's it. We now have our solution set. Okay, let's have another example. 2x minus 5 is equals to 9. Again, for the statement 1, it says that you have to take out the expression inside the absolute value notation. So it is 2x minus 5 and equate the positive value of our right hand side, which is 9, the positive. And for the second statement, you have to take out again the expression inside the absolute value notation and equate the negative value of a right hand side, which is the negative of 9 is negative 9. Okay, negative 9. Okay, let's solve this one first, this first statement. Again, what are we gonna do with this negative 5 here? We have to what? We have to eliminate this, so we were left with x. So to eliminate that one, we have to add 5 on both sides. It should be on the both sides, okay? Now we can cancel this out. And we are left with what? We are left with 2x. So what is 9 plus 5? It is 14. Now, is this our value of x already? No. We still have to divide this by 2. Now, this can be cancelled out. Okay, let's have another color. This will be cancelled out because 2 divided by 2 is 1x or simply x. Because we're left with x. And 14 divided by 2 is 7. So we now have an x here. Okay, for the second statement, we have to add 5 on the both sides. And this will be eliminated and we are left with 2x. And what is negative 9 plus 5? It is negative 4. Now let's divide this by 2. Now we're left with what? We're left with x. What is negative 4 divided by 2? It is negative 2. Now, to check if 7 and negative 2 is our solution, we have to do the checking. So let's do the checking here. Checking. In doing the checking again, we have to copy the what? We have to copy the original equation. Okay. Is equals to 9. Now, let's substitute first the values, the 7 to the x of our original equation. So, 2 times the value of our x, which is 7. This is 7 class. And minus 5 is equals to 9. Now, what is 2 times 7? It is 14 minus 5. Now, what is 14 minus 5? It is 9. Okay, the continuation is here. So, 9 and 9. Now, what is the absolute value for 9? It is 9. Equal or not? It means that our 7 here is our solution set. 7. But let's check if negative 2 is also our solution by doing our checking. Okay, let's do the checking. Let's substitute. Okay, checking. Checking. Now, let's substitute negative 2 on our x to the original equation. So, 2 times negative 2 and 9. Question mark. So, what is 2 times negative 2? It is negative 4, then negative 5. So, what is 4? Negative 4 minus 5. It is what? Negative 9. So, what is the absolute value for negative 9? It is 9. This is equal. It means that x is equal, our negative 2 here is also our solution set. Okay? Let's have another example. X is equals to negative 2 is equals to 0. Okay. For the statement again, for the first statement, we have to take the expression inside the absolute value notation and take the positive value of our right hand side. Now, same goes like on this second statement, but we have to put the negative 0. Okay, do we really have to put negative 0? There's no such thing as negative 0 actually, class. So, you simply put 0 here. 0. Okay, so for the statement 1 and 2, they're both the same, right? Okay, so let's solve for this one. So we have to add 2 plus 2, and this will be cancelled out, and we're left with x is equals to what is 0 plus 2? It is 2. Same goes like this. Because there is just the same. Cancel out and 2. Now, let's do some checking. Okay. And in doing the checking, we have to use the original equation, which is x is equals to 2, minus 2 I mean, and 0. And let's substitute this 2 here. So, 2 minus 2. Okay, so what is 2 minus 2? It is what? It is 0. Equal or not? The absolute value of 0 is still 0 and it is equal. So our solution set is 2. Now, I will no longer do the checking for this one because it is still the same. So it means that 2, okay, it means that 2 is also our solution set. Solution set. But if you observe that 2 and 2 here are the same, right? Since they are both the same, we can simply write our solution set as this one. Just write 1, 2. Okay. Let's have another example. Example 8. Again, we have to take the expression inside the absolute value notation, which is 2x minus 7 is equals to 25. And for the second statement, you have to take the expression inside and take the negative value of the right hand side, which is negative 25. Okay, so let's solve this first statement. So we have to add 7. And now this will be cancelled out and we are left with 2x. What is 25 plus 7? It is 32. Now, let's divide it by 2. So this will be cancelled out and we are left with x. So 32 divided by 2 is 16. For this one, we have to add 7. This will be cancelled out and you are left with 2x. What is negative 25 plus 7? So what is negative 25 plus 7? It is what? It is negative 18. So let's divide this by 2. This will be cancelled out or simply 1x. What is negative 18 divided by 2? Negative what? Negative 9. Now let's do some checking. And doing the checking, you have to copy the original equation. And let's substitute first the value of x. So 2 times 16 minus 7 is equals to 25. And okay, let's continue it here. So what is 2 times 16? It is 32. 32 minus 7. What is 32 minus 7? It is 25. Now, what is the absolute value for 25? It is 25. Equal? Yes, it is. It means that our solution set is 16. Now, let's check if our negative 9 here is also our solution. Okay, let's do some checking again. Let's substitute. Oh, I erased negative 9. Okay, let's substitute negative 9 on our original equation. Negative 9 minus 7. Now, what is 2 times negative 9? It is negative 18. What is negative 18 minus 7? It is negative 25. Now, what is the absolute value for negative 25? It is 25. So, equal or not? It is equal. It means that x is equals to negative 9 is also our solution set. Okay, we're done with example 8. Let's move to example 9. Okay, if you observe, there is a variable outside. Okay, if you notice that we have here a variable outside the absolute value notation. So, for this one, what are we going to do is to first eliminate this. So to eliminate this, we have to add 4 on the both sides. Now this will be cancelled out and we are left with x plus 1. The absolute value of x plus 1 is equals to 3 plus 4, 7. And this is our new equation. Okay, now since we have this already, Let's use the two statements. For this statement 1, we have to take the expression inside the absolute value notation, which is x plus 1 is equals to, and equate it with the positive value of the right hand side, which is 7, right? Okay, for, okay, 7. For the statement 2, you have to take again the expression inside the absolute value notation and equate the negative value of the right hand side, which is negative 7. Now, let's solve first the statement 1. So we have to subtract 1 here, and this will be eliminated. And we are left with x is equals to 7 minus 1 is 6. For this one, I have to eliminate minus 1. And this will be cancelled out since 1 minus 1 is 0. And we're left with x. So what is negative 7 and negative 1? It is negative 8. Okay, now to check if x and negative 8 is our solution set, let's do some. Again, do not forget to do the checking. We cannot just simply assume that x and negative 8 is our solution set. Now, in doing the checking, some of the misconceptions is you are going to use this new equation. But that is wrong. In doing the checking, we have to really use the original equation class. So this is x plus 1 minus 4 and equals to 3. Now first, let's substitute this x is equals to 6, which is the 6. So 6 plus 1 minus 4 is 3. And x plus 1 is what? 7 minus 4 is equals to 3. Now, what is the absolute value for 7? It is 7. So, minus 4 is equals to 3. Now, what is 7 minus 4? It is 3. Equal or not? It is equal. It means that our 6 here is our solution set. But let's check if negative 8 is also one of the solution set. So let's do again some checking. Okay. Okay. Okay, so let's substitute so let's substitute negative 8 to our original equation. So negative 8 plus 1 minus 4 is 3. Question mark. Now, negative 8 plus 1 is what? Negative 7. Now, what is the absolute value for negative 7? It is 7. So what is 7 minus 4? It is 3. Equal or not? It equal. It is equal. It means that negative 8 is also our solution set. Okay, I hope you are still following. Okay, for the next example. Okay, same concept with our example 9. So the first thing we have to do is to what? Eliminate this one. Minus 3. This will be cancelled out and our new equation is x, the absolute value of x minus 7 is equals to 5 minus 3. It is 2. Now we already have this new equation. Let's follow the two statements. So we have to take the expression inside okay, and 2. And for the second statement, you have to take the expression inside the absolute value notation and equate the negative value of the right hand side, which is negative 2. Okay. In writing this one, okay, I have committed a mistake. When following the two statements, you no longer have to write the absolute value notation. This is also one of the misconceptions because you're still writing on, you're still writing the absolute value notation, which is no longer needed because you are simplifying already the absolute value equation. Okay? Now, let's add 7 here. And 7 plus 7 is 0, so this will be cancelled out. And we are left with x. So 2 plus 7 is 9. Now, for this one, add 7. This will be cancelled out, and we're left with x. And negative 2 plus 7 is what? It is 5. Now, let's do some checking again. If 9 and 5 is the solution set. Okay, checking. And by doing the checking again, let's follow this original equation. So the absolute value of x minus 7 plus 3 is equals to 5. Now, for this one, we have to substitute 9 onto the x. Okay. 9 minus 7, okay, minus 7 plus 3 is 5. Now, 9 minus 7 is 2 plus 3. So what is the absolute value for 2? It is 2. And plus 3, 2 plus 3 is 5. Equal or not? Equal. Means that 9 is our solution set. 9. Now, how about our 5 here? Okay. Okay. Let's do some checking. Let's substitute it. 5. So this is 5 minus 7 plus 3 is 5. Now 5 minus 7 is negative 2 plus 3 is 5. Now what is the absolute value for negative 2? It is what? It is 2. So plus 3. Now what is 2 plus 3? Is 5. Equal or not? It is equal. So 5 here is also our solution set. Okay, so I hope you are still able to follow. Okay, so let's have another example. And I think this is the last example. Now, for the first step, we have to follow the two statements. So for the first statement, take out we have to take out the expression inside the absolute value notation. So it's x plus 1 and equate it with the positive value of the right hand side. So what is the positive for negative 4? It is 4. Now for the second statement, we have to take out the expression inside absolute value notation and equate it with the negative value of the right hand side, which is negative 4. Now, let's focus here on this first statement. So what are we going to do to eliminate this one here? So we have to subtract 1 in the both sides. Now this will be eliminated since 1 minus 1 is 0. Now we're left with x is equals to what is 4 minus 1? It is 3. Now, for the second statement, had to eliminate 1 also. And this will be cancelled out and we're left with x is equals to what is negative 4 minus 1? It is negative 5. Okay, now to check whether this 3 and negative 5 here is our solution set, let's do the what? Let's do the checking. Okay, for the checking. Now, for the checking, again, we have to write or we have to follow the original equation, which is this one. Now, let's substitute this 3 here to our original equation. Let's do negative 4. So, what is 3 plus 1? It is 4. Now, what is the absolute value for 4? It is 4. Now, the question is, equal or not? It is not equal. This means that 3 is not a solution to our equation. Now let's check this second statement, the negative 5. Okay, so let's write again the original equation. And let's substitute this negative 5 here to our x. Okay, so what is negative 5 plus 1? It is negative 4. Okay, do not forget to write question mark. Now, what is the absolute value for negative 4? It is 4. Now, equal or not? It is not equal. It means that negative 5 is also not our solution. Now, the question is, what will be our solution set? So, our solution set will be an empty set, since both of the statements or both of the values that we solved did not equal to our equation. So this is our answer. This is an empty set. Okay? Okay, solve the following linear equation is involving absolute value. You show your solution, the checking, and the solution set. You try and you comment down your answers. Your solution sets on the comment box section of our channel in this video. So I hope you learned something. Let's enjoy learning. Bye!